Hello everyone, today I want to talk about all the exponent rules. And basically what I mean by exponent rules is basically like the power of a number, right? And that power is how much, like I already described itself multiple times. Basically the power is how much the number times is itself. So you usually see it like this is the number, and this is the number that's kind of the number that's times in itself, like so, and this is the number that's timesing. I mean, yeah. I mean, timesing is not even. I mean, basically, yeah. This is the one that's doing it. For example, 3 to the power 3. That will be 3 times 3 times 3. 1, 2, 3, 3 over here. It's pretty logical. Let's go on the actual laws or rules. Basically, the first rule is the product. Of powers, and basically that rule is like a n. So basically, if the base is the same, and these two can be different, if there's a times, you basically just add them as long as the base is the same. So yeah, so an example of this, let's say 3 times I don't know, why am I putting it 4? So let's say this. You might think, okay, would that be 3, 2 because there's a 0 here, or what? No, each number has an invisible 1, so the answer would be 3 to the power 3 because, like, over here there's 2, or 3. And over here that's still a 1, so 3 and 3. Yeah, it should make sense. And let's say if they're shown kind of like this, right? Well, let's say 6 and then times, 8, 10. So basically, if they're shown like this, it's still the same thing. It will just be A16. So yeah. I'll just delete all of it. So now let's talk about the. Okay, no, this is not. I mean, it is. Quotient of powers. So basically, what quotient power means is basically when you are dividing them. Here, basically, again, same base. Most of the rules are all about same base. Basically, these exponents being subtracted by each other, and the explanation of that is basically like this. So 4 take away 2 is going to be 2, and it doesn't matter if it's like this or if it's like this. It's the same thing. So yeah. Now I didn't want to delete it, but it seems like I will. So now let's talk about power of power. And what basically that means is like this type of thing. Like if there's a number in the brackets and that number in the brackets has a power. This basically means that the exponents, they times each other. Like, I understand that you might think that, oh, but this means times and times is plus. You maybe, but at the same time, no, because this is different. Like, over here, there were times in, like, by the numbers, and over here, the times in by the, what's it called? Quotient. So, yeah. So, basically, very easy examples. Let's say 2, 3, like, it's just going to be these two times, so 2 to the power of 6. And let's say you have something like this. You might think, this might confuse you, but 1 times 10, it's just 10. So, yeah. Now let's talk about something similar, power of a product. So what I mean by this is, this time in brackets there are 2 numbers, and what that means is basically like the exponent goes to both numbers and they then times each other. So yeah, let's say we have x to the power of 3. So this is 3 and x to the power of 3, and that is 6 to exponent 4. Basically that is, then the 3 gets a 4, and then times these 2 times x, 12. So yeah, it is quite simple. Now let's put some, like, let's have 4 to the power of 2, and then 6, and all of that to the power of 2. So equals 4 to the power of 4, which is, 4 times 4 is 16. 16 times 4 is 40. 64, and that times 40, so 240, and then this 16, 156, 256. Let's just check if I'm right. Yep. And then 6 to the power of 2 is just 36, and then basically, why am I even finding them out? It's going to be, I mean, no, you should find them out, but then basically it's going to be these numbers, right, times each other, and I'm not going to work that out. I'm just showing you how it works. So after that, power of a quotient. So what I mean by this is, let's say we have fraction in brackets and they are powered. It's basically the same thing as last time. 2 to the power of 2, 4 to the power of 2, right? And then 2 times 2, 4 times 4, which is just 4 to 56. So, I mean, that was an example, but let's have something like this. So we powered the 3. Oh wait, so this is the question, right? And what equals is 3 to the power of 3, right? And then let's put them in brackets, x, and so it's less confusing. I'll do it like this for now, and then I'll make it a 9 inside the brackets, and then this to this, 7, 3. And what that equals is basically 3 to the power of 3, 27, and then x to the power of 9, and then 330, yeah. So, and before that, also the 0 exponent rule, So what this rule is basically, let's say you have something to the power of 0, it's always a 1. Always, even if it's like a huge number, it's going to be a 1. And the reason is, so let's say we have something like this, right? So exactly the same thing, and like basically when we divide, we take away the numbers, right? So 2 to the power of 0. However, you might think, okay, so how is it a 1? If it's 2 to the power of 0, the 2 is still there. No, because when you divide something, right? And so let's say how much 6 is in a 6? The answer is 1. Same here, it's a division, so it's equal to a 1. Like, it's the same thing as this. You see the vision? Now, wait. Now let's talk about negative exponent rule. So, negative exponent rule is basically, let's say you have a negative exponent. It basically means you put it like this to make it positive, because you can't have a negative exponent. It's no. And let's say, for example, if you, like, another version of this rule is, let's say you have something like this, right? What you do, you just open the brackets, and basically after that, you open the brackets, but the numbers, they switch and the exponent becomes positive, so it will be like this after that, and it will be like to the B, I guess. No, it would just be here. It would be powering both of them. It would be like brackets but without brackets, so probably like this. Yeah, but like it's like this. Yeah. So let's say we have 6 to the power of minus 2, that just equals 6 to the power of 2, and like you don't have to open that, you don't have to do the actual calculation, because like, yeah. Okay, now let's say we have something like this. We just open the bracket and just flip the numbers, and then, yeah. Now let's just go to a hard question straight away. Like, let's say we're gonna use kind of all the laws that we know here, kind of. Okay, first of all, let's check what we can do here. Well, we can get these two times, which is 12. Then a and the a like times, which is going to be a3. Then these two times, and it's going to be b5. Then we should open the brackets, and the brackets are going to be 3 to the power of 2, a to the power of 4, b to the power of 6, and 3 to the power of 3 is 9, a4, b5, and after that we have to, like, this cancels, and then we have to divide them. So let's just divide these first. What goes into both of them is a 3, so 4 and 3, and then when you divide these, they go negative, so it goes like this, and then to make it positive, we move it here, which will be a 1, but you don't have to write it because 1 doesn't change, and then a 1 here just times the number over here, so it doesn't really matter. You don't have to write it down, but you can. And that's kind of that mini section. So now let's talk about rational exponent rule. So basically the rule is that, let's say you have b and it's like this, that basically equals like n b m. Like, oh wait, I wrote this bad. So the number and then n b mn, right? This is the number, this is the exponent. The exponent is a fraction, right? So this is what equals in brackets. This is in brackets and this is in brackets. But that just basically equals this also. So this one is in the thingy-majiggy. So let's just go to example. So 3 squared 27 2. So that just equals to 3. So over here, it is quite hard to understand it, but look, basically, from this stuff, we know that this is equal to this. And what I mean by this, so look, the n is outside, right? So this is kind of like, we're able to move it here, but not just as a 3, it's going to be like this, like as a fraction, because I don't really understand the reason myself. However, because it's kind of like we're making it would be a negative, but to stop making it a negative, we make it into a fraction straight away. Kind of like that. And what this means is basically it's asking us what number times this is like itself to give us like 27. What number times is itself 3 times to give us 27. So 3 times 3 times 3 equals 27. So the number is 3, and it's just going to be a 3 because we cancelled this thing. We kind of solved this. And then we have the 2 left. It's going to be a 2, so this equals 9. Easy. Now we have something a bit more harder. Let's say we have something like this. So something like this, right? Then we open the bracket 81, 49, and it becomes positive. So then we just put them like this. And then what we're able to do, so look, basically we know that m is on the top, so we're able to make this type of thing. We're able to make a bracket, if that makes sense. Like we're able to move it, so we can do this. Wait, too much knowledge to hold. So something like this. And basically this asks what number times itself to give us 81. That's 9. This is 7. So we have the 3's left, and that's 7 to 9 over 3, 4, 3. So yeah. Now let's have another question. So before actually solving it, you have to know that square root, it automatically has a 2 here, because yeah. So there's this one, and after that should be it. Okay, so basically let's go solving it. So when we open this, it's going to be m2 to the power 4, and that just equals a 2. So this is m2 to 2, and then this times in itself is just m minus 6, and these were times, and when you times them, these two add, so that the on the top is going to be minus 4, but let's just leave it like that for now. After like this, we have to solve. We're gonna put the p having, so p 1 2, because that's what the rule says. This thing is on the bottom, and whatever is this, it could be here, it has to be on the top. This just equals to basically, let's just leave it like that for now. And then we have q minus 3 2. So after that we also have m here, and that m has a 1, but that's later. After that, since these are not real numbers, we don't exactly have to solve them, we just kind of have to simplify it as possible. So what we have now, we have this and this. Well, they're dividing, so they do this thing. No. And so minus 4 minus 1 equals minus 5. So on the top we'll have minus 5, but we're going to move it on the bottom to make it positive. And after that we're going to move this one on the top because it has a negative fraction. Q, 3 over 2, and then the p is where it was. So we don't add ones because it doesn't matter basically. And also when you go top to bottom, you don't actually even have to. I mean, I guess you do, but we don't even talk about it because like it doesn't matter. As if like, because that's just how maths works. One doesn't do anything. Or yeah. Now, let's talk about equality of exponents. So the rule equality of exponent is basically if, like, you know, if these two are equal, that means m and n should be equal, kind of logical, and that is for solving like problems. So let's say we have this type of problem, right? What we do here is basically we kind of change one of them. We can change one of the numbers. So let's say instead of having a 30, we do 6 squared because it's the same thing, and we get something like this. And then we open the brackets, 6, 2 squared minus 2. After that, since we never mind, instead of a 8, it's supposed to be a 6. I'm sorry. So, and since now the bases are the same, we can just forget about the bases for now and just have these things being equal. So it's basically like a normal moving question or whatever it's called. So x on one side, x1 because it's negative, and then this here, so 7. So yeah, x equals 7, and then yeah. So before I leave, so let's say we have questions like 5 to the power plus 4 to the power 4. What do you do? Because there's no law about plus. It's, mate, you just put it in a calculator, if I'm honest. But you just open the bracket, this, no, use the exponents 25 plus 625, and then, yeah, it's just the same with minus. Whatever you do, you just, yeah, take it away. So that's all. Thank you.